Hi everyone, welcome back to chemistry. In this video, we're just going to dive a little bit deeper into the nuclei of atoms. So remember in the last video we said that the nucleus of an atom has the protons and neutrons, and then orbiting around the nucleus are the electrons. We also said that protons have a positive charge, specifically a positive 1 charge, and electrons have a charge of -1. And then that neutrons have no charge, or are neutral. So what I want us to make a note of is that unless I tell you otherwise, assume that atoms are neutral. So let's make a note up here. Unless told otherwise, assume atoms are neutral. In the future, we'll look at atoms that are not neutral, and there's a special name for those. But for now, assume that unless I tell you otherwise, an atom is electrically neutral, meaning it has no charge overall. So if an atom has no charge overall, but we've got these pluses and minuses, what does that mean for the number of protons and electrons in any given atom? Well, it means that the number of protons has to equal the number of electrons so that they'll cancel out. So this is a carbon atom and we have 6 protons, and each of those protons has a positive charge. So right now, just looking at the nucleus is contributing, 6 plus charges, positive charges. And then on the outside, right, we have our electrons, and we have, let's count, we've got 1, 2, 3, 4, 5, and 6 of them. So 6 minus charges. So you'll see here that this carbon atom is neutral, right? These neutrons here are not contributing to the charge. The positives, we've got 6 of them, are protons, and we've got 6 negatives. So those charges cancel out. And this is what's happening in any neutral atom. The number of protons is equal to the number of electrons. So if you know the number of protons, you can figure out the number of electrons. Okay, so how do we know the number of protons? Well, the number of protons in the nucleus of an atom is called the atomic number, and we give it the symbol capital Z. And that atomic number not only tells you how many protons are in the nucleus of any given atom, it's also kind of like an identifier for what type of atom you have. It's an identifier for what type of atom you have. So what do I mean by that? So when we look at this periodic table here, looking at hydrogen over here, hydrogen has this little 1 right here above the H. So I've noted that in blue. So that is the atomic number for hydrogen. Looking over here at helium, we've got an atomic number 2. For lithium, over on the left now, that's 3. For beryllium, 4. Boron, 5. Carbon, 6. Nitrogen, 7. Oxygen, 8. Fluorine, 9. And so on. You'll notice that none of these elements has the same atomic number. And the reason for that is that each element has a different number of protons in the nucleus of the atom. So for carbon, our example up above, carbon has 6 protons, and it's also atomic number 6. That's an identifier. So if you have an atomic number of 6, you are carbon. If you have an atomic number of 8, you are oxygen. If I ask you to find the symbol for the element that has the atomic number 18, you would tell me argon, Ar. So let's practice this a little bit. So how many protons does each type of atom have? You'll need to consult your periodic table. All right, so boron. How many protons does boron have? And how will we figure that out? So let's go up to our periodic table, and we're looking for boron. Let me give us a little bit more room here. So we're looking for boron. First off, which one is boron? Yeah, boron's this one here. So looking at boron, right, we see some things there. There's boron, the name, right, written out. There's the symbol B. There's that 5 up there. And that 5 is our atomic number, right? And what does that atomic number tell us? Yeah, it tells us the number of protons. So atomic number equals number of, remember we can abbreviate protons P plus. So I'm going to write that like that. So boron has how many protons? Yeah, 5. 5 protons. So if boron is an electrically neutral atom, and we're going to assume it is because I haven't told you otherwise, and it has 5 protons, 5 positive charges, how many electrons should it have? Yeah, 5, right? Those positive charges have to cancel out with our negative charges in order for boron to be neutral overall. All right, what about nitrogen? Let's get rid of this here. So nitrogen is over here. Its atomic number is 7, so it should have 7 protons, and it does. That's what makes it nitrogen. All right, what about iron? Iron's a little bit of a different one, Fe, right? So we're going to look on the periodic table for Fe. And it's okay if this takes you a while at first. You'll get the hang of where things are, but Fe's right there. And then I'm noticing that it's atomic number 26. So that means it has 26 protons. What about chlorine? Chlorine's over here. Atomic number 17. So we have 17 protons. All right, now this says how many electrons does each type of atom have, assuming that the atom is neutral. If you said 5, 7, 26, and 17, you would be correct. So let's put that here, 5, 7, 26, and 17. Same number of positive charges as negative charges. Same number of protons as electrons. All right, so we have a way of figuring out how many protons are in an atom, and we know how, if we know the number of protons we have in an atom, we can figure out the number of electrons. But what about neutrons? We haven't really talked about them a whole lot. They kind of get the short end of the stick sometimes, but they are really important. So to figure out the number of neutrons, I first want to tell you about something called the mass number. So the mass number of any atom is given by the symbol A, capital A, and it's the sum of the number of protons and the number of neutrons. So mass number equals number of protons plus number of neutrons. And let's just take a second to think about why that is. So remember we said in the last video that the mass of any given atom is really only due to the protons and neutrons. And that's because in relation to the protons and neutrons, electrons are really, really tiny. So protons and neutrons are the ones that are contributing the most to the mass of any given atom. So sometimes you'll see an element kind of written out in this form here. And let's break this down a little bit. So on the right is just you write your atomic symbol or your element symbol. So, what is it? Carbon, oxygen, fluorine, lithium, beryllium, hydrogen, whatever. What element do we have? And that's where that X is. Over here on the left and kind of down is the atomic number. So how many protons are in the atom? What's the atomic number of that atom or that element? And then up here is the mass number, and that's the number of protons plus the number of neutrons in an atom. So look down here over at this example here for a second. We've got our element symbol on the right there, carbon. And then on the bottom we have a 6. Why is it 6 there? Yeah, because carbon has an atomic number 6. So let's go back up to our periodic table up here. We'll locate carbon and we'll say, oh, okay, carbon is atomic number 6. So that means it has 6 protons, right? And then over here, what's this number? Yeah, that's our mass number. That's our mass number for carbon. So looking at this representation of carbon, we can tell a lot of information just from this small symbol here. We can tell what kind of atom we have. We can tell how many protons we have, which means we can also tell how many electrons we have, assuming it's neutral. And then we can also figure out how many neutrons we have because we know the mass number. So if we know the mass number, we also know the number of protons, right, from our atomic number. Can we get the number of neutrons? Yeah, we can do a little bit of algebra. So that's what I have here for you. I've actually rearranged that equation up above to show you how to solve for the number of neutrons. Okay, but the idea is you're going to take the mass number, and if the mass number is the number of protons plus the number of neutrons for carbon, what is the number of neutrons? Yeah, 6. 6 neutrons, right? 6 protons plus 6 neutrons equals a mass number of 12. Or you could plug in the numbers here. So we've got a mass number 12. We've got 6 for our atomic number. So we must have 6 neutrons. All right, let's practice this a little bit. So pause the video, try it out, and then come back. All right, so for number 1, hydrogen. How many protons, neutrons, and electrons does hydrogen have here? So protons, what'd you guys put for that? I got 1 proton because we've got an atomic number 1 down here. Okay, remember the bottom number is our atomic number. All right, what's the top number? Yeah, that's our mass number. And I know that the mass number equals the number of P plus protons plus the number of neutrons, and 0. So for this one, my mass number is 2, and I have 1 proton. So how many neutrons? Yeah, 1 neutron. All right, how many electrons? Yeah, 1 electron, right? Protons and electrons must equal each other if we have a neutral atom. I haven't said that this is not neutral, so we're going to assume that it is. So we have the same number of protons. Oops, dropped my pen here. Protons and electrons. Pretty cool, right? You can get a lot of information from just this small symbol here. Okay, so let's try the next one. Again, P plus equals, N0 equals, and E minus equals. So for P plus, how many protons do we have? Yeah, 8. Right? Atomic number 8. If you go to the periodic table and you look for the 8th element, you're going to find oxygen. How many electrons then? Looking over at this column. Yeah, 8, right? It's a neutral atom. I haven't told you that it's not neutral. All right, our mass number of protons plus the number of neutrons. If our mass number is 18 and I have 8 protons, that means I have 10 neutrons. All right, fluorine. How many protons? Yeah, 9. How many electrons then? Yeah, 9. And then how many neutrons? Yeah, 10. Because our mass number is 19, we've got 9 protons. So we're going to subtract those 2 numbers, and that's going to give us the number of neutrons. All right, so that's it for this video, but come back for the next one and we'll talk about isotopes.